Hey students, it's Mr. Pouts. So we're going to talk about just a second part of section 4.4, and this is going to just be a quick one about continuous and discrete graphs. Since our goal here, I'll remind you, is to graph equations that represent functions. We're going to talk about a couple different types of graphs, and they are continuous and discrete. So in the last video, we talked about what these two are. A continuous graph is a graph that is unbroken, or it just continues like that. You look here, there's no breaks in this graph. But a discrete graph is a graph that is composed of distinct isolated points. So right here we have distinct points. They wouldn't continue from point to point. Now when we talk about linear equations, they always continue, but these discrete graphs, depending on the situation, might not make sense to continue between the points. So we're going to look at a problem and identify whether it's continuous or discrete. So we've got this example right here. Farmer's market. A local cheesemaker is making cheddar cheese, is making cheddar cheese to sell at a farmer's market. The amount of milk used to make the cheese and the price at which she sells the cheese are shown. So those are the two different things we might graph. Write a function for each situation, graph each function. Is the graph continuous or discrete? So, let's look at the milk one first. Well, we'll look at so the milk one. If you look over to the left, the weight W of cheese in ounces depends on the number of gallons M of milk used. So W equals 16M. So the weight is always equal to 16 times whatever M, however many gallons it would be. Make a table of values. If we look over here, the amount A of money made from selling cheese depends on the number N of wheels sold. So A equals N 9n, make a table of values. So we're going to make the table of values here. Not sure why that happened again. With our equation. So if we plug in 0 for m, which when we're graphing, this would be on the x-axis and this would be on the y-axis. But if we look at this, 0 gallons of milk would be equal to 0 weight. You have 1 gallon of milk, plug in for m, you get 16. 2, 32, 3, 48, 4, and 64. Now if we look over to the right, we're talking about A would be the money, and N would be the number of wheels sold. So if we sell 0 wheels of cheese, we make $0. We sell 1 wheel of cheese, we pulled it in for N, multiply it by 9, you get $9 made. 2 wheels of cheese would be $18, 3 wheels of cheese would be $27. Now our job is to graph it and decide if it's continuous or discrete. Alright, so if we look over to the right or left here, it says, how can you decide if a graph is continuous or discrete? It says, decide what values are reasonable for the independent variable. For example, if 3 and 4 make sense, do 3.3 and 3.7 as well and see if that makes sense. So the independent variable, let's look at the x's. So the first one, the independent variable, is the m, which deals with gallons of milk. Could we have, in the middle of there, could we make a half a gallon of milk? Sure. You can buy half gallon of milk. So we could have stuff in between. So that, I think, would be continuous because we could put stuff in between. Now let's look at the x one. The n, or the, sorry, what we make for money based on number of wheels sold. So n would be the number of wheels of cheese sold. And 0, we could sell 0 wheels of cheese. We could sell 1 wheels of cheese. Would you sell 1.5 wheels of cheese? I don't think so, because that wouldn't be a wheel of cheese. It comes as a wheel. It doesn't say you can sell half wheels of cheese. Sorry again about that. So when you graph it, if you look to the weight of the cheese, you can have half gallons. You can have stuff in between. So that's a continuous graph. But for the wheels of cheese, you only sell one at a time. 1 wheel, or 0 wheels, 1 wheel, 2 wheels. So this is going to be a discrete graph because it's not going to make a lot of sense to put anything between. So again, it's just looking at it and seeing if it makes sense, the independent variable. Now I'm going to see if you get it. So why don't you try this one on your own? The first one, it says graph each function rule. Is the graph continuous or discrete? And give a reasoning. So do that for each of A and B. All right, so the first one we have says the amount of water W in a wading pool in gallons depends on the amount of time in minutes the wading pool has been filling. So you're filling up a little pool, um, and you got your little pool here, and over time the water starts filling up more and more as time goes on. So it has the function rule W equals 3t. So I made a little graph here. Um, over for the left. I label it with the W equals 3t. And again, if we look at the equation, t is our independent variable, which would be our x-axis, and W is our dependent, which would be our y-axis. So if I were to plot these, you plug in 1 for the for the time, you get out 3 gallons of water. 2 minutes would be 6 gallons of water. 3 minutes would be 9 gallons of water. 4 minutes would be 12 gallons of water. 5 would be 15, and so on. Now, the question is this continuous or discrete? Could you have, in the middle here, for instance, 1.5? Could you have 1.5 minutes? And would it be right here? Well, yes, it would. After 1.5 minutes, it'll be between 3 and 6 gallons. So yes, this one would be continuous. All right? It makes sense that you could continue it between the time increments here. Look at the second one. The cost C for baseball tickets in dollars depends on the number and of tickets bought as related by the function rule C equals 16n. So the cost, obviously, if you're going to buy tickets to a basketball game or baseball game, the more tickets you buy, the higher the cost is going to go. So let's graph that. I made this graph here with tickets on the bottom and cost on the left because cost is affected by tickets. So if we graph it, one ticket is $16 because you plug in 1 for n. 1 times 16 is 16. 2 tickets would be $32. 3 tickets would be $48. 4 tickets, again, that would go up. That would be up to 16 more dollars. Would be $54, and so on. Now the question is, could we continue? Could there be in-betweens? So let's look at here. Could you have 1.5 tickets? I don't think so. I don't think they allow you to buy half tickets. So this one would stay like this. This would be discrete. We would not connect the dots. So it would be a discrete graph. All right? And that is the difference between continuous and discrete. And that is all we have for this lesson. So hopefully that ties us back to our goal of graphing functions and representing functions. Have a good day.